graph. So hang on, let me get that set up. So here's the AISpace tool. I am going to show the legend over here in the corner just so you can see what the different colors represent. And I said I want to load the Vancouver neighborhood graph. There we go. And I am going to go into view now, and I'm going to click on show edge costs so we can see the actual costs in here. And if you look at this, you can see that the start node is the purple node in here. So we're starting at UBC. And we are going to our goal node, which is SP. And of course, again, we could have multiple goal nodes if we wanted to. In this case, we just have one. All right, so let us do this lowest cost search demo. So let's go into solve mode, and we'll go into search options, and we're going to do lowest cost first search instead of depth first or breadth first like we've been doing recently. And there's not a very good way to show you this much bigger, so we will just see how it goes. I suppose I could drag stuff out a little bit, but I don't really think it's going to help you all that much. So let's see. If I go to the view, font size, we'll make it large, but not extra large. Yeah, that's just beautiful. Hang on. Okay, I've squidged this up a little bit. It's probably a little bit less authentic in terms of Vancouver, but it fits a little bit better. In fact, let me pause again and just squidge a little bit more. You can watch me squidge for a minute so you can see what I'm doing in here in case you use the tool. I've selected select, and I'm just going to kind of move stuff up just a little bit more. I want you to be able to see the weights on these edges, but it would be really nice. There we go. That's just a little bit flatter so that when we go into solve, there you go. Look at that. That's not so bad. And we can do that and stretch this out a little bit. Great. Okay. And so remember, we are doing the same basic algorithm, but we now are using a priority queue. So I'll do find step just to show you what I'm doing here. All right. So starting at UBC, going to SP, and remember we are doing lowest cost first search, so we have a priority queue. So I'll do a find step. We'll take UBC off of the frontier. We will find its neighbors, right? There's just two of them, and we will add them back to the frontier. Now notice they both have a path cost of 3, so they're put onto the frontier in arbitrary order. The front of the priority queue is at the top of this list. Okay, so now we will take off this path UBC to KD. So let's take a find step. We take that off. We say, who are the neighbors? Well, we've got JB and MP. If I do the UBC KD to JB, that's 7. Well, let's do the step to show you who the neighbors are, right? Now, the order they get put back on has to do with the path cost. So as I said, UBC KD to JB, well, that's 7. UBC KD to MP, that's 6. So we would expect the UBC KD to MP to show up on the frontier higher in this list, right? Higher priority than the other one. So if we do a find step, look at that. The UBC to KD to MP, right? This one appears earlier in or higher up in our priority queue, has better priority than the other one, right? So if we take another find step, we take the UBC to JB off the frontier. It has only one neighbor, right? So that's going to be pretty boring. We just put that back on. What was the distance there? It was 7, right? So 7, so it arbitrarily goes either in front or below this one. Now we'll take off this path to MP, UBC KD to MP, right? And we will pop that off. Shouldn't really say pop, but we'll take it off of our queue. Off of our priority queue, off the frontier. And now we're going to look at the neighbors of MP. So let's do a find step. And MP has a bunch of neighbors. And if I take another find step, you'll see all those neighbors got put on here. Here's the 3 neighbors from MP, right? And MP's 3 neighbors got put on in terms of the total path length, right? So UBC to KD to MP to RM, UBC to KD to MP to RM has 3 plus 3 plus 3 is 9. And so that has a path cost of 9. Look at that. But UBC KD MP KB, UBC KD MP KB is 4 plus 3 plus 3. So that's 10. So that's got a path cost of 10 in here, right? Okay, so let's do a few more steps. We'll take another find step. So we took that UBC to KD to JB off because that had the lowest cost, right? We find the neighbors of JB. It's just this KB, right? So we'll take a find step. And that will be 3, and 4 is 7, and 4 is 11. So that's going to get added on either right before this one or right after. I think the way this algorithm does it is it puts it at the very back of the queue. So there you go. Take the front of the queue off again, which goes to KB. And look, this one gets to KB in 11, but this one gets to KB in 7. So that's looking much better. So we'll take a find step. And we'll find the neighbors. There's 2 neighbors. And we will add those new paths on in the order that they appear, right? So we're taking them on, and we have the, stop it. We have UBC to JB, sorry, UBC to KD to MP to RM. Where's RM? Down here. That appears higher because things, if there's a tie in the priority queue, it looks like it puts the newer one on later, and that's okay. Same priority. We'll get through it. Let's do another find step. So we'll take that first one off with RM. We'll find the neighbors of RM, and one of them, that SRY thing, is far. So let's see what happens. So there we go. So here's our new frontier, right, with all these paths. Now we'll pull this guy off again. Find step. Who are the neighbors of DT? It's just SP. And let's see, 3 and 4, 7, 8, 9, 10, 11. Okay, so that's going to get put on behind that guy, right? So we got the neighbors, and we're going to put it back on. And we need to just check that this 10 hasn't solved it yet, right? So let's see, what do we get here? So, oh, there's a bunch of 11s. All right, so we'll take a find step. We pull this guy off. We find all its neighbors. And we add all its neighbors on by figuring out how long they are and adding them. So we're going to have 3, 6, 10 plus 6 is 16 to get to this one, and 12 to get to that one. So we'll take a find step, and there's our 16, and there's the 12, right? That's what we just added. I'll show you the front of the priority queue because that's a little bit more interesting to us right now. And we're almost there. We'll pop something off. Right, we will find the neighbors. Oh, it doesn't have any neighbors, right? There's no out arrows. So it just goes away. We're done. And now we take the next one. And we're doing this one with KB. Remember that every time we take something off of the frontier, we check, is the very end of the path the goal? So is the very end of the path goal? No, it's not the path goal. Let's take another find step. Okay, we got the neighbors. Let's put them back on in priority order. And where are we? What's the top priority queue? Look at that. Something goes to SP. So we're going to take it off the queue, finally, priority queue. And we're going to say, hey, check it out. That's a goal. So we win. Yay, we found the goal. Right? Path cost 11. Cool.